Well, welcome back, folks, to another exciting JLab Bio exclusive. Today, our focus is going to be on reaction. I can't say that word. I will, but you know why. Reaction stoichiometry and limiting reactant. So we're kind of shifting gears here, moving back towards stoichiometry unit. Should be a pretty straightforward unit for you guys. I know that you've experienced this before, but again, I want to make sure that we're all on the same page here. We're all in good shape, so let's see what this unit's going to be about. By the end of this video, you should be able to explain how mole ratios impact the amount of reactants and products in a chemical reaction, and you should also be able to convert between moles, atoms, molecules, and grams of any substance in a chemical equation. Vocab terms for this unit, we've already talked about molar mass and mole ratio a little bit, Avogadro's number. We're also going to focus on percent yield, limiting reactant, and excess reactant into this particular video. So hopefully you remember from one of our previous units that we can convert between atoms, moles, and grams using several different conversion factors. Remember that molar mass is grams per mole, and that information is found on your periodic table. If you remember, we learned how to calculate that a few units ago, and along with calculating that with compounds. We also looked at Avogadro's number, 6.022 times 10 to the 23rd, and that is the number of atoms, molecules, or particles in 1 mole of something. So again, hopefully you have a really good idea of how to do these conversions. We're just going to look at them when we convert between reactants and products in a chemical reaction instead of just converting them within the same reactant. So when we convert between two different chemicals in a chemical equation, we need the mole ratio. Before we do that, we actually need the balanced chemical equation first, because that gives us the ratio of moles between different species of chemicals. That comes from the coefficient of your balanced chemical equation. We then use this as a conversion factor between moles of one substance and moles of another. So please keep in mind that the only way that you can change between moles of one substance and moles of another is if you go through the mole ratio. Let's do some practice problems and go from there. When potassium iodide reacts with oxygen, it produces potassium oxide and iodine gas. How many grams of iodine are produced from the reaction if 43.3 grams of potassium iodide reacts with an excess of oxygen? So again, we need to first write out our balanced chemical equation. We're going to start with potassium iodide reacting with oxygen to produce potassium oxide and iodine gas. So we need to make sure we write this out correctly using the same rules that we've talked about in our chemical equation unit. And balance. So the question asks, how many grams of iodine are produced in the reaction if 43.3 grams of potassium iodide react with an excess of oxygen? If you see the word excess of oxygen, you do not need to worry about utilizing it in the problem. So we're going to start with 43.3 grams of Ki. Again, this is all dimensional analysis stuff that we've talked about previously. Whatever unit is on top of the first step must go on the bottom of the next. Grams convert directly into moles. We find that information on the periodic table. Again, same thing. Whatever is on top of the first step goes on the bottom of the next. So we have Ki on the bottom. We want to be able to get it to grams of iodine, so we need to go to moles of iodine. And again, we use the coefficients of our balanced chemical equation, so that's going to be 2 and 1. And since it's asking for it in grams, we need to go from moles to grams of iodine. Everything looks like it's set up correctly. All of our units cancel out, except for grams of iodine, which is perfect. We need 3 significant figures in our answer. And just plug in your calculator and solve. What we end up with is 33.1 grams of iodine. All right, simple enough. Let's do one more practice problem. If 27.5 grams of strontium phosphate react with excess sodium chloride, how much strontium chloride will be produced in molecules? So again, we need to make sure that we write out our balanced chemical equation first. So let's do some strontium phosphate. Sodium chloride. We're going to get strontium chloride out of it. and sodium phosphate. We need to make sure that our equation is fully balanced. And now we can proceed with the rest of the problem. So we're going to start off with 27.5 grams strontium phosphate. Grams of strontium phosphate to moles. Again, we're going to use the mole ratio to get to strontium chloride. That's 1 to 3. Again, coefficients of your balanced chemical equation. And it's asking for it in molecules, so we're going to use Avogadro's number here. And we just plug into our calculator and solve. 3 sig figs in our answer, so we have 1.10 times 10^23. Should use proper units, molecules of SrCl2. Again, same stuff we've done before, same stuff we've done last year. All right, let's move on. Another key concept we want to talk about is percent yield. Now, percent yield is very commonly used in industrial chemistry to determine how efficient the reaction is. So what we do is we measure the percent yield by dividing the actual yield, which is what you get, divided by the theoretical yield, which is what you should get, and multiply that by 100. So ideally, 100% is the ideal percent yield. You should get what you should theoretically get. Makes sense. Sometimes it'll be lower, sometimes it'll be above, and usually that's due to experimental error. But we can do problems associated with this as well. Let's take a look. Nitrogen reacts with hydrogen to create ammonia using the Haber process. How many grams of ammonia can be created using 38.4 grams of nitrogen? What is the percent yield if the actual yield is 22.8 grams? So let's write our equation. So nitrogen, remember that is a diatom. Hydrogen. Ammonia. H3. Balance our equation. And start our stoichiometry. 38.4 grams of N2. Grams of nitrogen to moles of nitrogen. Or that is a diatom, so you need to multiply your molar mass of nitrogen twice. Two moles of NH3. And again, we want our grams of ammonia. And then again, we just plug in our numbers and solve. Remember, we get our molar masses here and here from the periodic table, and these numbers here come from your mole ratio. So let's do our math and get how many grams we should get. So what we should end up with is 46.7 grams of NH3. So since that's what we should get, that is our theoretical. Our actual is listed in the problem. So in order to get the percent yield, we're going to take our actual divided by our theoretical, and we're going to multiply that by 100. And what we get is 48.8%. Okay. So again, just another type of problem that you may encounter in our stoichiometry unit. One more type of problem and we're good to go. So the other type of problem is if one of our reactants is not given in excess, it gives us another number. Okay, and that is known as our limiting reactant. So you're given two numbers to start with rather than just one. Well, if you're given both reactants, you need to solve for both. That is, you need to make sure that you convert both of those to your product. Because one of them is going to produce a lower amount than the other, that is going to be the correct answer. and the reactant that produced the lower amount is said to be the limiting reactant. The other is said to be in excess. So again, you do two stoichiometry problems in one. Whichever one is lowest is the correct answer. And then the reactant that produced that amount is known as the limiting reactant. Let's do one more practice problem and we will be done. If 18 grams of aluminum chloride react with 24 grams of sodium sulfate, how many grams of aluminum sulfate are actually produced? Which reactant is limiting and which is in excess? So again, first thing we need to do here is a balanced chemical equation. I'm going to write that here up at the top. Make sure we balance our chemical equation. And again, we take a look here, we have two starting materials. So both are going to need to be converted to aluminum sulfate. And whichever one is less is the correct answer. So let's get going. I won't talk much during this part. So after all that hard work, I actually get my two answers. Now, which one is the right answer? Well, remember, it is going to be the one that is the lowest. So that would be this one right here. So that's your actual answer. Now remember, we also asked for what is limiting and which is in excess. So since this reactant here produced the lower amount, we say that that one is limiting. Okay, which would make AlCl3 excess. Again, I know it's a bit of a long-winded problem, but if you guys have any questions on it, make sure that you let me know. And again, we'll continue working with these problems a little bit later on. So hopefully you got everything in from the learning objectives for this video. Again, if you guys have any questions moving forward, let me know. A little bit long video, but again, stoichiometry, well, take some time. We'll talk to you later, guys. Have a great day. Bye-bye. Oh, don't forget to like, subscribe, and shop merch as well. Really important. And comment down below.